This example is on page 275 of the textbook, and it says the Best Bread Bakery wants to determine its daily profit from bread sales. This graph shows the data gathered by the company. So we see profit is dependent on the price per loaf. And here 2 points are indicated. This is the first point with coordinates 0.75 and 300. Means that when the price per loaf is 75 cents, the profit is $300. And this is the vertex of the parabola. Has the coordinates 1.75 and 400. Means that when the price per loaf is $1.75, the company makes a profit of 400. And here's the question. It says, what equation represents the relationship between the price of the bread and the daily profit from bread sales? So since we have the vertex and a point, we're going to come up with the equation in vertex form. Vertex form looks like this. Y is equal to a, x minus h squared plus k. And our task is to find the values of a, h, and k. So to do that, we're going to use the two given points. And the point here is 0.75, 300. And then the vertex is 1.75 and 400. And we're going to sub these coordinates into the vertex form of our equation in order to solve for a. So this is very similar to what we did with the factored form, except in the factored form, we subbed the zeros and the point. But here, since we're writing it in vertex form, we're going to sub in the vertex and the point. So the point has coordinates x, y. The vertex coordinates are labeled h and k. And then if we take those numbers and plug them in, we get here 300 is equal to a times 0.75 minus 1.75 squared plus 400. Next, you're going to evaluate this part. So 0.75 minus 1.75 is negative 1. When we square negative 1, we get a positive 1. So we have a times positive 1, which is just 1a. So next line, we would have 300 is equal to 1a or a plus 400. Next, we subtract 400 from both sides to get a by itself. So 300 minus 400 is equal to a. That means a, when I subtract 400 from 300, is equal to negative 100. The final equation that models the profit is going to be y is equal to negative 100 times x minus 1.75 squared plus 400. Okay? So remember to leave x and y as variables to show that y, the profit, depends on the price per loaf, which is represented by x. Okay? In this example, it says that a parabola has a vertex at 3, negative 6. It passes through the point 5, 14, and we're asked to determine the equation of the parabola. Here we're not given a graph, we're just given a point and the vertex straight off the bat. So we can label the coordinates 5, 14 as x and y, and then the coordinates of the vertex as h and k, and then sub them into our vertex form to give us 14 is equal to a times 5 minus 3 squared. And then instead of writing plus negative 6 when I replace the k value, I'm going to simplify the signs, just put minus 6. And I'm going to evaluate this part here. 5 minus 3 is 2. 2 squared is 4. So I have 14 is equal to a times 4, or 4a, because we write the number before a variable, minus 6. Okay. Next, to get a by itself, I have to add 6 to both sides, which gives me 20 being equal to 4a, and then I divide by my coefficient of 4 both sides to give me an a value of 5. The final equation, therefore, is going to be y is equal to 5 times x minus 3 squared minus 6. And this is the equation of the parabola. It has a vertex at 3, negative 6, and passes through the point 5 and 14. Okay. The next example is a word problem. It says the underside of a bridge is 6 meters high and 10 meters across. Find an algebraic expression in vertex form that models the shape of the underpass. Now, it's going to depend on how you draw this on a Cartesian plane. You can draw the underpass with one leg at the origin. So here is what it might look like. So we have one leg at 0, 0. Okay, and it says that the bridge is 6 meters high, so that the vertex here has to have a y-coordinate of 6. It also says that the underpass of the bridge is 10 meters across, or from one leg to the next is 10 meters. Okay, in order for us to write the equation in vertex form, we need to know the coordinates of the vertex and one other point. Well, we know one point is 0, 0, or we can use 10, 0. Doesn't matter which of those two we use. The vertex we only know the y-coordinate of, but we can find the x-coordinate because it has to be between the two zeros here. So a number that's halfway between 0 and 10 is 5. So the vertex has the coordinates 5, 6, and then the point that you can use is either 0, 0 or 10, 0. It's completely up to you. You'll get the same answer regardless of which point you choose. So if I label these, x will be 0, y will be 0, 5 will be h, and then 6 will be k. And then I can sub those into the vertex form to help me solve for a. So 0 will equal to a times 0 minus 5 squared plus 6. Evaluating this part, 0 minus 5 is negative 5. When squared, it gives me positive 25. So 25 times a, which gives me 25a plus 6. Okay, now I subtract 6 from both sides, which gives me negative 6 is equal to 25a. Dividing both sides by 25, I end up with negative 6 over 25 as my a value. And I can leave it in fraction form. Now for my final equation that represents the underpass here. I'm going to write y is equal to negative 6 over 25 times x minus 5 squared plus 6. So that's one way to model it. Another way is if you put the middle of the base of the underpass right at the origin. So your graph would look something like this instead. Okay, maximum height is still 6. And if this is 0 and the base has to be 10 meters across, we would have this at 5 and this other leg at negative 5. Okay, so now my vertex will have the coordinates 0, 6. Okay, and a point I can use is either 5, 0 or negative 5, 0. I'm going to use 5, 0. So 0 is my h, 6 is my k, 5 is the x, 0 is the y. Subbing these in, I get 0 is equal to a times 5 minus 0 squared plus 6. 5 minus 0 is 5, squared is 25, so 25 times a gives me 25a again. Subtracting 6 from both sides gives me negative 6 is equal to 25a. Then dividing both sides by 25 gives me the exact same value for a, because the shape of the parabola is not going to change regardless of how you model it. So we should expect to get the same answer. Okay, but now for the equation, we end up with negative 6 over 25 times, and the next part we would have x minus 0, which can be simplified just to x squared plus 6. Okay, so either this equation or this equation can be used to model the underpass. It's completely up to you which one you want to use.